Hi, I'm GUO CHENG GUANG, topic of primary 6. Right now here, we're still at ordinary differential equations. Well, for ordinary differential equations, this time it will be about the operators. But here, we're going to give examples. Well, for this time, we're just going to have one of these examples. And we're going to use a method that we have already learned before against this operator method. So we're just going to compare those two, whether at last what we get is the same. So for the example this time, this second derivative of y, and then you have to add 5. Then the first derivative of y, then 6y. And this part, it will be equal to, we start from the simplest, x squared perhaps. So we have this part. Then the first method is the method that we have learned and used before. So this first method, it is actually just by coefficient comparisons. So by the method of coefficient comparison, so that means we can just say we let this y be. We have to think about this, whether is it x squared or is it x cubed. So this y, that means you'll have the highest power. First derivative, it will lower the power by 1. Second derivative, lower the power by 2. And this, on the right hand side, this power is a 2. And if this is a 2, that means the highest power here is only 2. So that means it goes to this y. So that means you need to have x to the power of 2, or x squared. But this coefficient in front, we're not very sure of that yet. So we need to leave it as a. But afterwards, there may be x, because x is possible. Then it also might have that constant. So this is what we're going to have for y. Then after that, we'll be finding for the first derivative of y. First derivative, ax squared, you get 2ax. Then for the bx would be a b. Okay. Then after that will be for the second derivative. Okay, this is the second derivative. Differentiate one more time, and all that you'll be left with is 2a. By this part, you need to sum all of these back inside. So the first part is still 2a. Now we have 5. The first derivative, then plus 6, the y. And this part is equal to x squared. Okay, just one part here. Okay, like this. So then after that, for this part, we can try to rearrange some of these parts. Like this x squared, all that you're going to have is a 6a. Then after that is with only x. So with x, here you have a 10a. Then here we're going to have a 6b. Then x. Then for those constant parts, here is a 2a, here's a 5b, here's a 6c, and this is equal to x squared. Okay, so this is what you're going to have. And that will mean 6a, from this part, it is 1. And just comparing on these two sides, this x squared, this side is 6a, this side is 1. So yes, you get this. Then after that, here, 10a plus 6b. For the part behind, you don't have any x, so that means actually just 0. Then afterwards, this constant part. For this constant part, since you don't have any other constants on the other side, so it is just 0. So it is all these together. So from this first part, you will get a is 1 over 6. Then from this part, 10a plus 6b is 0. So that means what you have here, let's say it is 10 over 6, but at the same time we also have to simplify that, okay? Then from this part, b, we move it to the other side. So you have negative, then 5 over 18. So you have something like this. But then afterwards, this last of this equation, you have to find out c. So the last of this part to find out c. So 2a, here is a 1 over 3. After that, here you have to minus. And this part is equal to 0. So from this part, c, you will be able to find it out as okay, so c, you'll find it out as 19 over 108 from this part. As you move to the other side, then you divide. So we have found a, b, and c. And so for this part, wait, let me just use up this space here. And so for this part, our y. This part, a, 1 over 6. 1 over 6x squared. Then b is negative 5 over 18. Then x. Then after that, c is 19 over 108. So this is the parts that you will have for y. Okay, so this is what you get for y. Then we're going to use our operator method right now, which is the second method that we are going to use. For this operator method, here, the second derivative, d squared y, then add on 5 of the first derivative, so it's dy. After that, 6 of the y. And this part is an x squared. So then, in this operator method, this y is just like we're taking out this y. Then the next part is to divide this to the other side. So what you get is y, that is x squared. Now at the same time for this, we can factorize it. So when we factorize this, whereas it can be written into d plus 2 and d plus 3. The next step is for partial fractions. So we get things like this. So this is for that partial fractions part. So in the next step, in the last lesson, we have already shown what will happen to each of these parts and it will be something similar to integrating factor. And so for this part, this is add 2. So it is e to the power of negative 2x. Then after you have to integrate. So we can write this x squared first. Then after that is the e to the power of 2x. Then after that, dx. That's it, you have the minus. So here's plus 3. So you get e to the power of negative 3x. So this is what you have. Now in the next part over here, we can start to move this e to the power of 2x into the dx, and here is e to the power of 3x into the dx. In this part, here is an extra 2, so I have to divide by that 2, so you get half. There are all these others, then d, e to the power of 2x. At this part, 3, so it's a 1/3. Okay, then in this next part, we're going to start using integrating factor. Wait, I mean integral by parts for this part, okay? So in this part, x squared e to the power of 2x is going to remain outside here first. Then after that for this part, you have to change these two positions. After you change these two, you can straight away differentiate x squared to take it out of that d. So that means what you'll get will be a 2. Then okay, you can put x in front of the e to the power of 2x. So x is then e to the power of 2x dx for this part. Then for this part behind, you have to subtract 1/3, then e to the power of negative 3x. Then after that, x squared e to the power of 3x. Then here you minus. So this part you minus, you have 2. Because that is a square, so you have a 2 outside. Then integrate x e to the power of 3x dx. Then afterwards, for this part, from here, this will be the same, but the behind, you just continue using integral by parts. But this part, since when you put this e to the power of 2x behind, you need an extra half. So this 2, it will be simplified. Then after that, when you integrate only with this e to the power of 2x dx, you need an extra half. So that here you have 2x. So then you have e to the power of 2x. But just as in the last lesson, we do not have the extra constant. Okay, the next part for here still subtract. Then 1/3 e to the power of negative 3x. First part is the same. Then after that here, 2. So x, then e to the power of 3x. So for that part, e to the power of 3x, you need to put inside the dx. So you need an extra 1/3. But beware, here's only 2, so you have an extra 2 over 3. There you have x, then e to the power of 3x. Then you add on. But since after that, it will only be left with e to the power of 3x, then dx. Put it inside, you need an extra 1/3. Then this will be what you get. So in the last part here, half, so you just times them all in x squared, then you minus half x at 1/4, then you subtract 1/3 x squared. That's why you have to add, be careful of this negative. So this is what you have. Then for the last part here, so x squares, you put them together. And in this case, you have 1/6 x squared. That's why for those x, you also put them together. Here's clearly a negative. So here you have a negative 5/18x. Down there is the last two constants. Okay, this part is a positive. So common denominators 108. Then after that is 27 minus 8, so it's a 19. And this is what you have for your y. Then when we look at it against this part before, it is actually the same. So that means this part, it will be alright. So that shows that they are both correct methods. Well, we can use them, but beware, this is for the particular solution part. Okay, so at this part, we actually can add on 2 more methods. At first we have 6, then these 2, they can also be considered as 2 of them. Coefficient comparison, and for this part is the operators method. So for all of these, if you want to continue to make sure that there is no more problems, you can choose to use differentiation, then you try to differentiate back to get the original part. Well, for this time, I'll not be using that. So I hope that you're all clear for this time. So I'll end here. And if you like our videos, don't forget to subscribe to our channel. Thank you for your watching.